Close your eyes and imagine yourself drifting quietly through the vastness of space. There are no engines here, no rush, no noise, just the silence of the cosmos and the faint glimmers of light from stars scattered in every direction. In this stillness, we begin a journey to explore something almost impossible to truly imagine: the observable universe. The term might sound technical, but it carries a beautifully simple meaning. It is the portion of the cosmos that we can actually see, or more precisely, the part from which light, or any signal at all, has had enough time to reach us since the beginning of everything. Beyond that horizon, beyond that limit, lies the unknown, perhaps endless, perhaps different in ways we can barely guess. But here, inside our observable bubble, there is already enough wonder to fill a lifetime of dreaming. The universe is old, unimaginably old, about 13.8 billion years in age. That number alone already feels heavy, stretching far beyond the scope of human history. Our own stories, our civilizations, and even the Earth itself are tiny compared to the grand sweep of cosmic time. Yet the observable universe is not only about age, it is also about distance. And here we find something surprising. Because space itself has been stretching and expanding since the very beginning, the farthest galaxies we can see are not just 13.8 billion light-years away. The true radius of the observable universe is about 46 billion light-years in every direction, making its diameter nearly 93 billion light-years across. Even though light has had 13.8 billion years to travel, the expansion of space has carried those distant galaxies farther away, and the observable universe has grown vast beyond simple imagination. And so we begin with this image, a cosmic sphere centered not only on Earth, but on you, the observer. Wherever you are, if you look outward into the darkness, the limit of what you could ever see forms a horizon. Every person, every galaxy has their own observable universe centered upon them, each one overlapping, each one a personal bubble of the cosmos. Tonight we will drift slowly through this bubble, chapter by chapter, gently uncovering its secrets. When we speak of the observable universe, it's tempting to picture a giant snow globe, an invisible edge surrounding us. But the truth is more subtle and more beautiful. The observable universe is defined not by walls, but by time. Because the speed of light is finite, it takes time for light to travel through space. We cannot see beyond the distance that light has had time to cover since the beginning of the universe. This invisible boundary is called the particle horizon. It is not made of matter nor of energy. It is simply the limit of what has been able to reach us, a line drawn by time itself. Think of it like listening to a distant echo. If the echo takes a moment to arrive, then you can only hear sounds that were made within that time limit. In much the same way, the observable universe shows us only the light that has had enough years, billions of them, to cross the expanding distance between there and here. Anything beyond that remains invisible, not because it does not exist, but because the signals have not had enough time to arrive. They may still be on their way, traveling slowly across unimaginable distances, never quite reaching us in this lifetime or in any lifetime at all. It is also important to understand that what we see is not the present state of those distant galaxies, but their past. When you look at the light of a star 100 light years away, you are seeing it as it was 100 years ago. For galaxies at the farthest reaches of the observable universe, you are seeing them not as they are today, but as they were billions of years ago, when the universe itself was young. In this way, looking outward is also looking backward, traveling through time as well as space. The farther we look, the closer we come to glimpsing the very dawn of creation. And so, the observable universe is not only a place, but also a storybook of time, with its pages laid out in concentric circles of distance, each one showing us an earlier chapter in the cosmic tale. At the heart of understanding the observable universe is the question of age. The universe, as best as science can tell, began about 13.8 billion years ago in an event we call the Big Bang. This was not an explosion in space, but rather the rapid expansion of space itself, carrying energy and matter outward in all directions. From that hot, dense beginning, the cosmos has been cooling, stretching, and forming the structures we now see: stars, galaxies, clusters, and the great cosmic web. The figure of 13.8 billion years comes from careful measurements of the faint afterglow of the Big Bang, known as the cosmic microwave background. This glow is a bath of radiation left over from when the universe was only 380,000 years old, a time when atoms first formed and the cosmos became transparent to light. By studying the tiny ripples and patterns in this background glow, scientists can trace the story of the universe, measure its expansion, and estimate its age with remarkable accuracy. To put this into perspective, consider the age of the Earth, about 4.5 billion years. Human beings in our modern form have existed for only around 200,000 years. Recorded history, the written story of our species, covers just a few thousand years. Compared to the cosmic clock, our presence is a mere whisper. We have found a way to measure and understand the vastness of the universe that surrounds us. And this is perhaps one of the most moving aspects of this story, that a small species on a small planet orbiting an ordinary star has managed to glimpse the age of the cosmos itself. The age of the universe is the foundation of the observable universe. It sets the scale for how far light has traveled, how far galaxies can be seen, and how much of the story is visible to us. Without this knowledge, the idea of the observable universe would be incomplete. With it, we begin to see our place in time and space more clearly as part of an ancient, unfolding story. When we look as far as we possibly can with the most sensitive telescopes, we encounter a boundary not of distance, but of light itself. This is the cosmic microwave background, often called the CMB. It is the oldest light we can ever hope to see, a faint glow that fills the universe in every direction, left over from the time when the cosmos was only a few 100,000 years old. Before this time, the universe was filled with a hot, opaque soup of particles. Photons, the particles of light, could not travel freely. They were constantly scattered by electrons and protons. But as the universe cooled, atoms formed, and suddenly the fog lifted. Light was released to travel across space, and it has been traveling ever since. To us, billions of years later, that ancient light has been stretched by the expansion of the universe into microwaves, invisible to the eye but detectable with instruments. Maps of the cosmic microwave background reveal an astonishing sight. Tiny ripples in temperature, differences of only a fraction of a degree. Yet these ripples are the seeds of everything we now see. They mark the places where matter was slightly denser and where gravity would later pull gas together to form galaxies and stars. In this way, the CMB is both a record and a promise, a record of the young universe and a promise of the structures that would one day emerge. When you gaze into the night sky, you are looking across the canvas that began with these ripples. Every galaxy, every star, every planet, including our own Earth, traces its origin back to these tiny differences in the early universe. To contemplate the CMB is to contemplate the beginning of all structure, the foundation upon which the observable universe has been built. As we move forward in our quiet journey, the universe begins to reveal its great structures. Galaxies, those luminous islands of stars, gas, and dust, do not scatter randomly like grains of sand, but instead gather into patterns, forming vast cosmic structures on scales almost beyond imagination. If we could step back far enough, much farther than any telescope allows, we would see that galaxies connect into filaments, like threads in a delicate web, stretching across the cosmos. This is the large-scale structure of the universe, often called the cosmic web, and it is one of the most breathtaking discoveries in modern astronomy. Each galaxy is home to billions, sometimes trillions, of stars. Our own Milky Way contains about 400 billion, and yet it is only one of hundreds of billions of galaxies within the observable universe. These galaxies gather into clusters, held together by the invisible pull of gravity. Between clusters lie vast voids, regions of near emptiness, where galaxies are rare. The contrast is striking, dense filaments glowing with light, woven around immense bubbles of darkness. Together, these filaments and voids form the skeleton of the universe, a structure shaped by both visible matter and the mysterious presence of dark matter. The beauty of this cosmic web is not only in its scale, but also in its quiet order. From the tiny ripples in the cosmic microwave background, gravity has pulled matter into strands, stretching across billions of light years. The web itself is not fixed. It evolves over time, slowly changing as galaxies merge, clusters form, and new stars are born. Yet even now, billions of years after the beginning, the basic shape remains, a network of light and shadow, stretching to the limits of what we can see. To lie under the night sky and imagine this hidden web is to feel both small and connected. Each star above you is a single note in a cosmic chorus, and each galaxy is a harmony of billions of voices. And beyond what you see, the filaments continue, threading together the vast expanse of the observable universe, binding it into a single, graceful whole. When we think of the observable universe, we often think first of stars. They are the most familiar cosmic objects, shining in our night skies, steady and enduring. Yet in truth, stars are far more than points of light. They are the furnaces of creation, forging the elements that make planets, oceans, and even life itself. Every atom of carbon in your body, every breath of oxygen you take, was once formed in the heart of a star. To understand stars is to understand the heartbeat of the cosmos. Stars are born in clouds of gas and dust, where gravity pulls matter together until the core grows hot and dense enough for nuclear fusion to ignite. In this process, hydrogen is fused into helium, releasing light and heat. Over millions or billions of years, stars continue this fusion, radiating their energy across space. Depending on their mass, stars may shine steadily for billions of years, like our sun, or burn quickly and die young, like the massive stars that live only a few million years before ending in spectacular supernova. In the observable universe, there are more stars than grains of sand on all the beaches of Earth. Their light, crossing time and space, allows us to see into the past, into galaxies billions of light years away. Some of the stars we observe today no longer exist. They have already burned out, but their light continues to travel, a memory etched into the fabric of the cosmos. And yet, stars are not alone. They gather into galaxies, orbit one another in clusters, and sometimes host planets like our own Earth. Their variety is astonishing. Small, cool red dwarfs that burn slowly and may outlive the universe itself. Brilliant blue giants that shine intensely and briefly. Stars swollen into red supergiants, glowing like embers before fading into darkness. Each one, in its way, is a reminder of time, of energy, and of the quiet persistence of the universe. As we drift past them in thought, we are reminded, without stars, there would be no light, no warmth, no life. They are not only the beacons of the universe, but also its storytellers, carrying within them the history of all that has come before. The observable universe is filled with light, with galaxies, stars, and glowing gas. But just as important, perhaps even more so, is what we cannot see. Astronomers have discovered that most of the universe is made not of visible matter, but of something hidden, something we call dark matter. Though invisible, it reveals itself through gravity, shaping galaxies, clusters, and the very structure of the cosmic web. Dark matter does not shine, absorb, or reflect light. We cannot see it with any telescope, yet we know it must exist, because galaxies spin faster than their visible mass alone can explain. Without dark matter, they would simply fly apart. Instead, they are held together by an unseen presence, a halo of matter that outweighs the stars and gas we can see. In fact, dark matter makes up about 85% of all matter in the universe, dwarfing the ordinary atoms that make up stars, planets, and people. The thought is humbling. Everything we know, everything familiar, is only a small fraction of what truly exists. The universe we can see is like the tip of an iceberg, while the hidden mass lies beneath, shaping everything quietly, invisibly. Dark matter weaves the cosmic web, guiding galaxies into filaments and clusters. Without it, the observable universe would look very different, less structured, less ordered, less alive with the forms we now know. What is dark matter? That remains one of the greatest mysteries of science. It could be made of particles unlike anything we've ever discovered, or perhaps it is something even stranger, beyond our current imagination. Yet even without knowing its nature, we can see its fingerprints everywhere, in the rotation of galaxies, in the bending of light through gravitational lensing, in the grand shapes of the cosmic web. To reflect on dark matter is to reflect on humility. We are reminded that most of reality lies beyond our senses, hidden in silence, yet still shaping the world we know. The observable universe is not only what shines, but also what whispers, unseen, holding everything together in its quiet embrace. If dark matter is the invisible glue holding the universe together, then dark energy is the quiet breath pushing it apart. In the late 20th century, astronomers discovered something astonishing. The expansion of the universe is not slowing down, as once thought, but accelerating. Distant galaxies are not only receding, but doing so faster and faster, driven by a mysterious force that we call dark energy. Dark energy is even more elusive than dark matter. It cannot be touched, detected, or measured directly, yet its effects are written across the sky. The light from distant supernovae, the pattern of galaxies, and the cosmic microwave background all reveal the same truth. Something is pushing space itself outward. Dark energy makes up about 70% of the universe, meaning most of reality is not matter at all, but this unseen energy filling the void. The consequences are profound. If the expansion continues, then over billions of years, galaxies will drift farther and farther apart. The observable universe, already vast, will grow emptier as distant galaxies recede beyond our horizon of visibility. Eventually, only our local group of galaxies may remain visible, the rest forever hidden beyond the speed of light. The night sky will grow lonelier, the cosmos quieter, though its true expanse will remain just as infinite. Dark energy reminds us of the strangeness of existence. The universe is not static, not steady, but dynamic, restless, moving outward in a long, slow breath. And though we may never fully understand the cause, we can feel its effect, shaping the fate of everything we see. As you imagine this quiet acceleration, think of the universe as a great ocean tide, slowly carrying galaxies apart, stretching space itself. Within that tide we drift, small and fragile, yet aware, watching the expansion of everything with eyes that can only glimpse, never grasp, the full immensity. As we drift farther and farther into our journey, we reach what seems like a boundary, a horizon beyond which we cannot see. This is not a physical wall, not a solid edge, but a limit set by time itself. Light travels at a finite speed, and the universe has existed for only about 13.8 billion years. Because of this, we can only see as far as light has had time to travel since the beginning. This distance defines the observable universe, and though the cosmos itself may be far larger, perhaps infinite, what we can perceive is limited to a sphere around us, about 46 billion light-years in every direction. This sphere is vast, unimaginably so, containing all the galaxies, clusters, and filaments we have spoken of. And yet, it is not the entirety of reality. Beyond it, there may be more galaxies, more stars, more structures stretching without end. But their light has not yet reached us, and may never do so. In this way, the observable universe is a kind of cosmic bubble, our horizon of sight, bounded by the speed of light and the age of time. Standing at this edge in thought is a humbling experience. Imagine gazing outward, knowing that every faint galaxy, every spark of light in the deepest fields of the Hubble or James Webb telescopes is part of this boundary. Each is a messenger from billions of years ago, carrying a story written before Earth was even formed. And just beyond that horizon, silence, regions of space forever hidden, their light trapped by the sheer immensity of distance. Scientists often compare this limit to standing at the shore of an ocean. You see the waves stretching to the horizon, but you know the ocean continues beyond what your eyes can perceive. The observable universe is our cosmic horizon. Beyond it, the vastness continues, perhaps endlessly, perhaps folding in ways we cannot yet imagine. The edge of the observable universe does not confine reality, it only confines our view. And so, when we look up at the night sky, we are reminded of two truths. We are deeply connected to everything we can see, and yet most of reality lies forever beyond our sight. The horizon is both a limit and an invitation, whispering softly of what remains unknown. When we look into the observable universe, we are not only seeing across space, we are looking back in time. Light takes time to travel, and the farther an object lies, the older the light we receive. When you look at the moon, you see it as it was about a second ago, the sun as it was 8 minutes ago, and the nearest star as it was 4 years ago. But when we look at distant galaxies, we see them as they were millions or billions of years in the past. The cosmos itself becomes a kind of time machine, letting us witness its history written in light. This is why the night sky is so powerful. Every point of light is not only a place, but also a moment in time. Galaxies, billions of light years away, reveal themselves as they were when the universe was young. Some of the faintest galaxies we can observe formed only a few 100 million years after the Big Bang. Looking at them, we see the beginnings of cosmic dawn, the first stars lighting up a universe that had been dark for eons. The further we peer, the more we approach the earliest moments of creation. Telescopes like Hubble and James Webb do more than show us pretty pictures. They peel back layers of time, letting us watch galaxies grow, stars ignite, and structures form. Each faint glow is a memory, preserved across unimaginable distances, offering us glimpses of a time when the universe was smaller, denser, and just beginning to take shape. To lie under the stars is to live within layers of time. Above you, the sky is not simply a flat canvas, it is a depth of history. Each star and galaxy, a reminder of moments long gone. Even as you breathe now, The light of the ancient past touches your eyes, connecting you to the very birth of the universe. The observable universe is not only a map of space, but also a record of time, stretching from the present all the way back to the first instant of creation. As vast as the observable universe is, we are a part of it. This truth, both humbling and comforting, lies at the heart of our reflection. On a cosmic scale, Earth is a speck, orbiting an ordinary star in a spiral arm of a modest galaxy. And yet, here we are, aware, reflective, and able to look outward with curiosity. In the immensity of time and space, we are small, but in our awareness, we are significant. Every discovery about the observable universe is also a discovery about ourselves. To know that galaxies gather into webs is to know that we belong to a greater structure. To measure the faint glow of the cosmic microwave background is to touch the very beginning of time. To observe starlight billions of years old is to recognize that we are part of a story that began long before us and will continue long after. And yet our smallness does not diminish us. Instead, it deepens the wonder. Imagine holding a grain of sand in your hand and realizing that the observable universe contains more stars than all the grains of sand on Earth's beaches. That comparison might make us seem insignificant, but consider this. Out of those countless stars and galaxies, consciousness arose here, on this planet, in beings who can ask questions, seek knowledge, and dream of what lies beyond. The cosmos is vast, but we are its storytellers. Our place, then, is not to dominate or to own, but to witness and to wonder. We are caretakers of a fragile world, observers of a vast universe, and participants in a story that connects the smallest atom to the largest galaxy. The observable universe humbles us, but it also invites us into reflection, compassion, and a sense of connection to everything that is. As our journey through the observable universe comes to a close, let us pause, breathe, and reflect. We have drifted from the beginnings of time, through the light of stars and galaxies, across the filaments of the cosmic web, and to the very horizon of sight. Along the way, we have discovered that the universe is both visible and invisible, filled with matter and energy we cannot fully explain, yet woven together in quiet, graceful patterns. We end where we began, with awe. The observable universe is not the whole of reality, but it is what we can see, what we can touch with our instruments, and what we can imagine with our minds. Beyond it lies more, perhaps endlessly more. Yet even this visible portion is enough to fill our thoughts with wonder and our hearts with peace. In the stillness of night, when you look up at the stars, you are looking not just at distant suns, but at history, at the fabric of time and space itself. Every photon that reaches your eye is a message, traveling across the cosmos, carrying with it the memory of where and when it began. To be aware of this is to be part of the story, part of the universe reflecting upon itself. And so, we rest here. We breathe deeply. We let the vastness cradle us in silence. The observable universe is immense, but we do not need to understand it fully to feel its presence. It is enough to know that we are within it, that we are connected to it, and that, for a moment, we are able to look outward and inward at the same time. The stars above, the galaxies beyond, the cosmic web stretching endlessly. These are not only distant objects, but mirrors of our own journey. And as we drift into calm reflection, we find ourselves part of the infinite, gently carried by the universe itself.